Okay, so now I am also recording the session. We were starting with the presentation of the subject. I have introduced myself. I'm Iago Diez, and I was talking about data science. Data science is in the intersection of these three big areas: some substantive expertise, some project dependent specialist knowledge, and then programming and math. The students in this course, some of them come from the double degree and probably know quite a lot of, or at least some math and statistics, and have lots of expertise in ecological management or forestry or even agriculture. The students from the information systems masters are probably more on this side, on the computation and programming, and again, math. And what I'm going to try to teach you here is at the intersection of the three things. Data science projects always happen in teams. So it is impossible for anyone to be a specialist in all of these areas. And usually you are specialists in one of them, know a little bit or maybe quite a lot about another, and then are working with people who know about something that you don't know so much about. And the goal of data scientists and of data science project is to work in teams and be able to work together to achieve something new and something different. So this is where our subject will happen. And it's okay, no matter what profile you have, even if you don't know much about one of these things, you can work with other people, you can just get a little knowledge about that and work in this type of data science project. That is what I would like to try to teach you during this classes. Okay, continuing with my own presentation, I come from Catalonia in Spain, from a little village called Banyoles, which has a nice lake, and you have a picture here. When I was in high school and middle school, I learned a little bit of programming. I remember one of my first codes was to do a small computer simulation that played the Connect 4 game. Okay, so even from a very, very early stage, I was trying to do some practical coding, and that has only gotten worse with time. In high school, I learned a little bit of math, derivatives, and integrals, these kind of things, and a little bit of programming and a little bit of general science, very little bit. Then I went to university in Barcelona, where I studied math. There, you might know Barcelona from the Sagrada Familia, or most probably from the Barcelona soccer team. In my studies of math, I got, of course, lots of knowledge about math and statistics and formalization of problems and so on and so forth. So in my own way to develop a profile in this thing that is now called data science, and at that moment didn't even have that name, high school gave me a little bit of the basis, and of course, studying math at university gave me lots of math, unsurprisingly. I then went to do a PhD in the University of Girona, to the north of Spain. There, I worked in several applied problems, and I improved my programming quite a lot. For example, we used to work with 3D point clouds and processing this type of data. This one was taken using the very famous at that time Kinect sensor for the Xbox consoles, and we would take different views of objects, like, for example, this very famous Stanford bunny, and match them. During the same time, and once I had already finished my PhD and started my postdoc, I also worked in medical image analysis. So a completely different area of application, but where I was using my very same programming and mathematical modeling, what you would call now data science skills. In this case, for example, you can see a project, some images from a project where we detected changes in multiple sclerosis patients. These images correspond to the brain of one person with a scan taken 1 day and 1 year later, and we devised algorithms to find differences. And once we had refined those differences, we could tell if the lesions that one person had due to this multiple sclerosis illness had progressed or had shrunk. This type of analysis was also done to use, for example, breast X-ray analysis to detect lesions that could be cancer. In these projects, we worked very closely with doctors. And of course, we didn't know anything about medicine. The doctors didn't know any programming at all, but we could all do this, what you would call now data science projects. And I hope during this subject, you can see how your skills could fit into one of these data science projects. Okay, so after school and university and even my PhD and postdoc, I got pretty good at coding. I'm a little bit ashamed that I put it so full. I don't think I'm that good, but I got confident at coding a little bit. Pretty practice in math and statistics too. And I got some knowledge in some areas, okay, even though I'm not a specialist in anything else than coding and math. Okay, computer vision. I have quite a lot of experience in that, and that's what I also want to talk to you about during this subject. Okay. When I finished my first postdoc, I flew from Girona to Sendai to Tohoku University, Tohoku Daigaku, where I worked for a couple of years. And then in 2017, I moved to good old Yamagata University, where I have been teaching since 2017 and having a blast, having a really, really happy time of it, okay? In Yamagata University, when I was hired, I set out to find new research collaborations in data science within the university and with other universities. That's also part of what took me to the Faculty of Agriculture in Yamagata University, which is set in Tsuruoka. And I have a very strong collaboration with the group from Professor Larry Lopez, and through him also, incidentally, to Turin University, where I'm also collaborating with some people. And as a result of that, we also have some people here from this double degree with this university from Turin. Okay, all in all, through this data science project, I have established a research network with lots of collaboration with people around the world, and I hope to be able to tell you a little bit about that during this subject too. Okay, I'm working in many different problems at this moment. Maybe the two main ones are the analysis of Japanese documents, historical documents. These are documents from the Edo period in Japan, and we try to analyze them using computer vision and deep learning and some of the techniques that we will learn in this subject. At the same time, as I said, I have a very strong collaboration with the Faculty of Agriculture in Yamagata University. And with them, we do quite a lot of drone image processing for images from forests in Yamagata, in other parts of Japan, and in other countries too. This is a course with different levels, which means that no matter if you're a beginner and no matter if you're already someone who can code, you can get different things from this course. And I'm going to try to explain which ones in each case. I'm going to also mention a little bit more about the language. Right? I said a little bit about that. I'm going to say a little bit more, the grades, and of course, ChatGPT and all that good stuff. About the course levels and the goals for each levels. Beginners in programming, in deep learning are welcome. The goals for a beginner, what I would like to teach a beginner would be to learn some code, learn to code in Python a little bit, okay? Enough to know what programming is, how programming works a little bit, and to complete the materials of the course. As you will see, the course will be evaluated from 3 projects, and I hope that you can complete at least a part of each of those projects. If you're a complete beginner, you will need to do a lot of coding on your own, and I will help you, but you need to ask for any help that you need, okay? You can communicate with me in web class. You can communicate with me in Slack. I posted a Slack link in the web class forum. So go look for them in the announcements, join the forum, ask me questions. I will answer as much as I can, okay? Apart from the regular lessons, it is possible to set up in-person meetings. Let's talk about that if necessary, okay? Apart from these basics of learning to code and so on, that good cut. I would like to teach complete beginners to understand the basics of computer visions and of deep learning and AI. Of course, AI is very popular now, and many people have experience of AI through, for example, ChatGPT. And I would like to get you to understand what ChatGPT is, what it can do, what it cannot do, a little bit more about all of those AI systems that now are around us, self-driving cars, all that good stuff. So I hope to provide an introduction to programming and to those other subjects for complete beginners. It's going to be difficult, okay? It's not an easy subject. You will need to make an effort, but if you do, I hope you will learn many things and have a good time. I don't intend to torture anyone. Just do the work, you will be fine, okay? Pro coders, people who already know how to code, are also welcome. Someone was answering the questionnaire saying, I already coded some deep learning networks in my graduation thesis, in my Sotsugyo Kenkyu. And I said, okay, that's fine. And then the person answered, but I didn't understand half of it. I understood about 50% of the code. Okay, that's an ideal profile for this subject. If you want to dig deeper, to understand more about how deep learning networks are implemented, how they work, why the results are sometimes good when you do the testing, the experiments, but then when you try to use them with new data, they are not so good. I think this can be the subject for you. Okay, so I will try to help you improve your coding skills. We will see some specific things, and to get hands-on practical experience on coding and evaluating deep learning networks. So those are my goals. If you are somewhere in between, you are not a pro coder, but you're not a beginner, I'm sure we can find material for it. Okay. In any case, ask questions. Let me know what you need, and we will do our best. This is a master level course. We don't have a completely strict list of things that we have to do. We can adapt to the needs of the students, which is a very, very good thing. Okay. So to lean a little bit deeper on this, if you're a beginner, the course contains some material that will be difficult for you to reach. Okay, some of the things are high level. Don't worry. Okay, no problem if some of the material is further from where you can get. Do not worry, you're not intended. The course contains material for different levels. I expect you to learn to program a little bit, to get better at it. You don't have to finish every last thing that's in the programming projects, and you can still get a good mark in the subject if you make an effort and if you make progress. If you're good at programming, some of the contents are easy for you, okay? That is okay. You don't have to spend a lot of time redoing things that you already know how to do. There is enough difficult material for everyone too, okay? So if you see something that's very easy for you, if you see something that's very difficult for you, don't worry, it's okay. Let me know in any case, okay? About language. So first, the programming language will be Python. There are many other very good programming languages around, but in my opinion, nowadays, for data science, for coding, the main language is Python. So that is what we will be using. And as we are all in different places, we will be using it with Colab notebooks, which will allow us to run our Python code online without having to install anything else than a web browser. As you are seeing, the communication language is English because of the particularities of the student group, but Japanese support will be given, okay? I'm going to speak a little bit in Japanese now to just drive this home. 科目の主な言語は英語ですけど、日本のサポートもあげたいと思っているんです。そのサポートの意味は何でしょうか？まだ 100% わからない。それから、少なくても日本語で質問をするとか、日本語で何かのことを提出するときは、日本語で私とコミュニケーションすることは大丈夫です。他のことが必要なら教えてください。コースの内容、その前のJupyter ノートブックのページは日本語のバージョンもあります。今日は授業終わるとき、一番目のプログラミングプロジェクトは英語だけ発表する予定です。それも日本語のバージョンが欲しい場合には教えてください。英語でするの理由は、今日のプログラミングの世界では、英語は本当に重要な言語です。それから、英語でできれば、主な科目の内容を上げるようにしてみます。でも、誰かが英語と大きな問題があれば、日本語のサポートも上げてみます。それから、問題があれば、ウェブクラスとか、Slack とか、メールとか、私には教えてくださいと解決してみます。はい。英語で続きます。Okay, so just a brief Japanese intermission to say that Japanese will also be supported. Today I will be publishing the first project from the course. It will be published initially only in English. If you need Japanese version, let me know and we will provide it. Okay. Okay. About the grading, there will be 3 projects, 1, 2, and 3, one for each of the big 3 blocks in the subject, and the final grade will be the average of those 3. Okay, important. You can submit as many times as you want. Okay, there will be a submission date. Anything submitted later than that will not be graded, so do not blow the deadline. But anything submitted earlier than the deadline, I will try to grade within 24 hours and give it back to you, and then you can submit it again. So if you do a few of the tasks of the first programming project, for example, and want to show me, then just submit them. I will grade them, give you feedback. This is right, this is not right. You have a problem here. All of this is fine. And then you can submit it again. So we can do this loop. You submit, I grade, I give it back to you, and then you submit again. And there is no penalty for submitting more than once. Okay? Just be advised. I'm busy sometimes, so the feedback might take a while. Usually I try to reply within 24 hours, but I make no promises. In particular, if you submit something on the last day, it's very likely that you will not get feedback because everyone will be doing that. So I recommend that you start early, submit whatever you have, okay? And we can work on that together a little bit. And I will be looking for progress and effort rather than the final result. If you can do everything perfect, it's great, but you don't have to. I hope that you will improve, that you will get better. About plagiarism and ChatGPT and all these things. I wrote here that plagiarism, copying your homework is not allowed. Maybe I would say that it's more precise to say that it's not recommended, okay? The point of the subject, the point of you doing this, joining this course, is for you to learn. If you just submit someone else's work, you're not learning much, okay? If I detect that, I will, of course, punish the people doing that. I'm not going to make a big effort to detect and pursue that. This is master level. I don't know. If someone is really intent and hell-bent on cheating their way through the masters, I don't think there is much I can do to prevent that, okay? Plagiarism is not allowed. Blatant things will be punished. And in general, I will not take a strong policy against pursuing that. About ChatGPT. ChatGPT and other AI tools, Gemini, Copilot, there are a million of them. Can be used to do some coding, but I really do not recommend it. So for example, if you're a total beginner, I would heavily advise you against using ChatGPT or Gemini or any of those to do your coding, because they will make it more difficult for you to understand what you're doing. They will provide you with complete solutions that may not be of the level that you need, that may or may not be correct, and you will not be able to tell the difference because you will just be beginning, okay? So I do not recommend to use them. It's not forbidden at all, but I think it's a bad way to learn, and it might be dangerous if you're a beginner. If you're good at coding, well, you already know about the code that these guys, these AI apps can do. And honestly, it's not great. Some simple things they can do very well, but if they can do them very well, it's very likely that you can do them very well, or you can find them in Google in 1 minute too. So while they can sometimes be convenient to redo simple things, you cannot trust them. You exercise your own judgment. If you're already a coder and know how to use those things and want to use them, go ahead, knock yourself out. It's, again, not forbidden. But they do suck at coding, and they are very dangerous because the code they give looks great always, but it's not always great. Sometimes it includes errors. It doesn't do what it's supposed to do, but something similar. So it can be very, very dangerous to use them. In particular, I have tried to use them for some of the projects in the course, and they give some nasty problems. So be very careful. The reflection that I always do to my programming students is, if you can only code what ChatGPT codes, why would the company need to hire you? They can just pay the ChatGPT version, and that's cheaper for them, okay? So please do not plagiarize. It's mostly going to be hurting yourself. I'm not going to police this strictly, but I will if something is very blatant. And I do not recommend using ChatGPT for the code, but again, knock yourselves out and use your own judge, okay? Okay, I'm going to give a course overview, but before I do that, let me stop for a second because, sorry. Let me stop sharing at this moment. Well, maybe that's okay. I have been introducing myself. I have been introducing some of the things that we will do in this subject. But I'm hopefully, this is not 100% sure, but I'm hopefully not going to be alone in this subject. You might have heard someone helping me in the background, and pending some details, we are very likely to be very fortunate to have a teaching assistant of exceptional level in this subject. His name is Moritake Kouma. He's an assistant professor at the Faculty of Medicine in Yamagata University and also doing his PhD with me from this April. And he will be lending me a hand in this course. And his programming level is very high and he's very good at answering students' questions. So you can trust him for your doubts and questions too. And I will ask Moritake to introduce himself for a second now.
Hi everyone, I am Koma Moritake. I entered the doctoral program in April. Until then, I worked as a mobile application engineer in a company. Yes, my English level is not high, but I'll try using English. Thank you very much.
Thank you very much. I think your English is fine. Maybe you can do also a brief introduction in Japanese.
OK。こんにちは、森竹コ馬と申します。今年の4月に野望研究室の博士課程 D11 年生で入りまして、で、自分の学部の卒論と、あと、修論も矢後先生のところで終えて、その後、会社でモバイルアプリケーションのエンジニアとして働いてました。はい。皆さんのサポートできること、嬉しく思います。よろしくお願いします。
Okay, thank you very much. So, this is we are hopefully going to be, myself and Moritake sensei. And let's just finish a little bit with the introduction of the contents of the subject, and then hopefully we can all do some coding, which is what we came here for in the end. So the course overview includes the 3 sections of the code of the course. Each section corresponds to one of the 3 programming projects that we will make the final grade. The first one is about structured data, which you usually experience through Excel spreadsheets or Google Docs spreadsheets or whatever. The second section will be about computer vision and managing images, manipulating them, seeing pixel values, and so on and so forth. And the third and final section will be about deep learning, and in particular, deep learning processing of images. Okay, that's why we do computer vision in the second one. For the structured data, we will do, for beginners, the goals are to learn the basics of coding, variables, functions, also loops, all that good stuff that you can find in the initial courses, but with a particular emphasis in text file input output. Okay. I would like to transmit to you that programming can be a way to do custom processing of your own research data. We will see from this initial project real data from, in this case, forestry application, and we will learn how to answer questions about that data using programming. For people who are already pretty good at coding, we will be seeing a little bit more profound, deeper contents. We will be seeing quite a lot about the pandas library. As I'm not teaching in Yonezawa, I'm not super familiar with the level of pandas coding from the students in Yonezawa, in Kogakubu. Please let me know if all of you are already super good at pandas and the contents in the projects are too easy, we will find other things, okay? We will also be speaking about functional programming and debugging and profiling at a little bit higher level using some of the tools in Python. That's the first course. The first project, sorry. In computer vision, we will be seeing images as matrices of pixels, counting those pixels, even though they might represent different things. And we will see how the NumPy library, which is a library to process basically consecutive data, what's called arrays, can be used to process images very, very fast. Images, especially nowadays, are huge containers of data. A single picture that we take with our smartphone contains millions of pixels easily. If we want to do any sort of significant data processing with image data, we need to do it fast. And the first and easiest way to do that fast is with the NumPy library. So I hope to give people who are beginning a flare of what the NumPy library can do and how images work and pixels in Python using the OpenCV library too. For people who are a little bit better, we will go a little bit deeper into NumPy and its NumPy tensors, and then tensors and arrays and how to communicate those with other libraries. We will use OpenCV and we will combine with pandas, with PyTorch, which I haven't written here, and we will do large-scale image processing using all of those things at the same time. Hopefully, that will be interesting and new for you. Finally, the last part is about deep learning. For beginners, first of all, what is deep learning? And hopefully do a little bit of history about the discipline and the things that it contains and what it means. I'm very interested in what AI can and cannot do. I think nowadays we get lots of input from news on the internet, general mass media news about AI. And I think most of the people writing about AI nowadays have no idea what AI is or how it works. And we get lots of very alarmist news or fantastic stories about what AI will be able to do next year. I'm very interested in the development of AI, especially in recent years. I also strongly believe that most of the things that are online today are bullshit. So we will try to pick one from the other and see what AI can do and what AI cannot do. In short, AI can solve many very detailed and repetitive problems, and that can be very useful in many areas. AI, on the other hand, cannot think in any significant way and will not be able to think in any significant way for the foreseeable future, in my opinion. AI is having an impact in our world, and it will continue to have it, and some of the things that it is doing can be pretty massive, but we will not be seeing intelligent robots around us anytime soon, in my opinion. So we will see where the limit is at this moment and where it's likely to move and where it is likely not to move, hopefully during the last part of the course. We will, in particular, speak about how to train deep learning networks, which is an important part of that previous conversation. And we will hopefully run some simple deep learning networks using Colab notebooks. For more advanced students, we will dig deeper into how deep learning networks work and how to implement them with the PyTorch library. There are several libraries for deep learning in Python. I think nowadays PyTorch is probably the most popular one, at least is the one that I use the most, okay? We will see the PyTorch dataset, which is an absolutely key piece of this library in order to be able to use the deep learning codes in a significant way, and likely part of the problem of the things that students that use deep learning do not understand at the beginning. We will speak about training, validation, and testing data. These three are similar but have very important differences, and understanding their difference can be the difference between being able to make pretty numbers for a graduation thesis or even a research papers, which are always fine and so on, but which are not the same as having a software that can be usable in practical situations. And that is what we want to get. That's what I am aiming for. Not something that looks good on paper, but then cannot really be used, but something that can provide practical results in application. Okay. Okay, so that is mostly all from me. Let's go for something different now. Let's do a little bit of coding. Let's try to start with a little bit of coding. This is a very simple coding example. Let's see if I can get to it. You have the link here. Let me see where else you have the link. You have the link in web class here in exercises. You can open it here, for example. Okay, yes. And I'm going to give you 5 minutes to read through this and to think about how to solve this. And then I'm going to start explaining a little bit about it. So for now, read this explanation, open this in your own browser using web class. Okay, let's go back to it. The web class page, exercises, click on exercises, and then click on this notebook, and you should open this Colab notebook here. Okay, exercises, and click on this link. If you have problems, write on the web class questions forum. Okay, and we will see. We will also test the way to communicate between ourselves, because we are going to be doing lots of coding during this course. So try to get this. Okay. So I'm going to give it another minute, and then I'm going to start telling you a little bit about this code from this very first Jupyter notebook. Okay, so let's get to it. The purpose of today's class is basically to do what we have already done and iron out the technical problems, which, as you have seen, we have some, establish a communication system between yourselves and myself, which we are doing. So please let me know of any problems that you have, either via web class or by the way, web class, you have the forum here, for example, questions, session 1 guidance. If you have any problem, you can post them here, okay? There is also a channel in Slack. Let me see if I can show it here. Yes. You have in web class announcements, many announcements in the presentation. And here, for example, you have how to join the Slack. So if you want, you can also address me in Slack through the image processing course. The reason for having these two communication channels is that the one that's easier, the one in web class, doesn't always work great, okay? Sometimes it takes a while for the messages to show up. So if you can join the Slack one, I will also be monitoring that one, whatever is more convenient, but please ask questions. Okay, so we are on this first coding assignment for us. It's just an example to exemplify the things that I want to show you in this subject. This is a toy problem, a very simple and silly problem even. But I'm going to try to use this solution to show how programming can give you a new perspective on things and can help you solve things in ways that are more sophisticated and can use the power of modern computers. Okay, so this is all predicated into this is all based, sorry, on one very popular mobile phone game called Pokemon Pocket, Pokemon TGC Pocket, which my kids play. My kids are at this moment 7 and 9, and they are all into Pokemon. And we try to limit their mobile phone time, and but as much as they can, they play this Pokemon themed card game. Okay. I'm not completely endorsing it. It's one of these games with lots of gacha mechanisms, and they will try to get your money. So I'm not telling you to go and play that, but that's the motivation, and they don't need any endorsement or any help from me, as they already have millions of customers. But in that game, there is currently something called a ranked mode, and you get points for winning battles. You have your own deck of cards, and everyone has their own cards and can build different decks, and you play against other human players with your deck cards, and you do battles which you have to win. In this ranked mode, you win points every time you win a battle, and you lose some points every time you lose one. And someone was asking the other day, how many battles do you have to win, or how many battles, sorry, do you have to contest, to fight, to do before you get from this ultra ball rank to the higher master ball rank. Okay. And the question is that when you win a battle, you get 10 points, and when you lose a battle, you lose 7 points. When you have reached the ultra ball rank, it means that you already have at least 710 points, and to reach the new one, the master ball rank, you need to get to 1,450 points. Okay, so this is a pretty simple question. How do you get from these 710 points to 1,450 points with these conditions? If you win, you get 10. If you lose 7. Okay. And there are many, many different ways to solve this. And the first problem is that we cannot implement the whole mobile phone game with all the decks and all the things, and especially we cannot get everyone to play for us and give us data. So in this case, we are having to simplify this making battles thing. So we are going to just assign a probability to winning or losing your battle. So in this case, what I'm going to do is I'm going to use some Python variables to model my problem. Okay. I'm going to, for example, consider the points for a win, and I'm going to put them in a variable called WP, win points. Okay, and that I said was 10 points. I'm going to consider the points for a loss, which are -7. Okay, and I'm going to consider the points that I need to advance from one level to the other, and those are what did I say? 740. Okay, so now I have 3 Python variables in this initial Python code that I have here, and they model my problem, the points for a win, the points for a lose, and the points in total needed. And now I need to model this winning or losing probability. And I'm going to suppose initially that winning and losing is something that happens with the same probability. So I'm going to make a new variable, which is called the expected points, which are the points for a win plus the points for a lose, which, if you remember, are negative. Okay. So I can even print this variable and run my code. This was not authored by Google, of course, it was authored by me, but we can still run it. And now I'm running our first Python code of the course. And the expected points for what would be every couple of battles, if we have exactly the same win and lose percentage, would be 3 points, because for every win that I get 10 points, and for every lose that I get -7. So in total, after 1 win and 1 lose and 1 loss, I am at 3 points. Okay, so then what I need to do is just compute the number of matches needed or battles needed are, and they would be the points needed divided by the expected points for every match, and then I have to do this times 2, because everything was after the expected points were after 2 battles. Okay, and now I have an error, coding error. Okay, which is also very, very frequent in programmers' lives. What happened? Points needed is not defined. Okay. Okay, because I called it point needed instead of points needed. Let me correct that. And now the number of matches needed are 493. okay, to get to this ultra ball level, because for every 2 matches I get this 3 points positive, and I need to get 740 in total. So this is a very, very silly, very, very simple way to think about our problem using programming, okay? But I can do a little bit better than that if I know a little bit more about programming. This thing I'm doing, I'm not using any thing advanced in terms of code. I'm only using the definition of variable, which is the very first thing that one learns when one learns to code, okay? Let me instead try to include this win probability, which was kind of implicit here in my calculation. So I'm going to need to use some library functions in this case. For example, I'm going to use the uniform function to be able to do random draws, okay? I'm also going to make a function here. Beginners here might be starting to get a little bit lost. Don't worry, a function is just a way to put up some code neatly stored in a way that I can reuse it later, okay? You can see all about functions in one of the first notebooks of the course, and we can look at it. We can answer any questions that you might have together. This function is going to have some variables, the points for a win, the points for a loss, the probability of winning, which we will transform into an explicit function, and then the start and end points needed, okay? And I'm even going to do here some documentation and say something like compute points from ultra ball rank to master ball rank, okay? I would need to make this better later, but I'm just going to save some space for that. And I'm going to use a simple loop for this, okay? I'm going to start with the number of points at the start value, and then a number to count the battles that I have fought. I start with 0 battles, of course. While the number of points is smaller than my end value, I'm going to keep doing battles, okay? And what will I do? So I will draw using this uniform function between 0 and 1, okay? If this draw is smaller than my win probability, then I will, as you can see now, Gemini is trying to help me, okay? Do I like it? I don't know, and I'm not going to bother, okay? So at this moment, but you could check it out and see if you want to use it. As I already know what I'm doing, I don't need to, so I'm not going to use it. If the draw is smaller than the win probability, then we get the points for a win, okay? If not, else, then we get the points for a lose, okay? Okay. And we have to update the count in any case. Okay. When we are done, we return the count. And we can, sorry, call this function here with something like this call that I had already prepared. Okay, and we run it once and we get this kind of code. As you can see, I ran it the first time, the result was something like 600, second time 284, third time 567, fourth time 622. I get different results because I have this random draw here, okay? So it's not like before where I was forced to admit that I always win one and lose one. So my win probability is always 50%, but I can change it here. In this case, I have also made it 50%, okay? But I could make it 20%. And then I would need much longer to compute this thing. What happens if the win probability is 20%? You see what's going on? I'm stuck in my loop, okay? Why? Because my win probability is so low that I keep losing, and my total keeps going down and down and down, and I never get out of this loop, okay? So let's stop this nonsense. What happens if my win probability is very high? Well, I finish much earlier, okay? So now I have a much more faithful modeling of my problem, okay? But perhaps we are not super happy with this code. It's a little bit long. It also gives different results every time we run it. Okay? So we can, first of all, let's try to make it a little bit more compact. That's more dedicated to the people with more experience in programming. But I think for beginners, it also gives you an idea that you can do code which is pretty simple. This only uses a basic while loop and a basic if loop, and you can learn how this works, I think, pretty quickly. And I think understanding this kind of structure should be the first place that all beginners should aim to get to, okay? I have done this very quickly. Don't worry if you didn't follow, it's normal. But try to understand it after reading the notebooks in this initial part of the course, okay? And you will get there. Sorry, let me go back there. Okay, and now we can also make the code a little bit more compact. In particular, all of this part is a little bit wasteful because Python has something called the ternary conditional. So I can do that points become, you know, I don't have to do points plus, I can do plus equals, and it's the same thing. And I can use the ternary conditional here. So if the draw, which I don't need to put into a variable anymore, is smaller than the win probability, the points will be added with the points per win, okay? And if not, they will be added with the points per loss, okay? So I have effectively transformed all of these if and else and points and so on into this simple line using the ternary conditional. Python has many, many ways to make the code shorter. And at first, they are more difficult to read, but once you get used to them, they make the code really, really compact and really, really easy, okay? And then what do I need? Well, not this anymore. I didn't need the draw variable anymore. I just need this. That's the same as before. It's much more compact now, okay? So we can run it again. But as I was saying, sorry, I don't know what I did here. Let me just get rid of it. Okay, cool. We have the problem that we have a code that gives a different result every time. So I'm getting a probabilistic answer to my question, and I don't want that. I would like to use the power of my computer to get some more information. So let's just turn this into a small experiment. Let's call this function many, many times and see what we get as an average for this value. Okay, so let's just import mean function and average function from the statistic package 2. Let's set a number of repetitions. Let's say what, 10,000. We would not do 10,000 repetitions by hand, but the computer can do them easily. Let's do again the points per win, points per loss thing. Points per win, let's say it's 10. Points per loss, it's -7. Let's say the win probability is 0.5. Okay. Start, we said, I'm repeating this because I don't want you to have to be running different cells to have different variables, okay? I'm going to have all my variables for this experiment in this same cell, okay? And is 1450, and then I could do a for loop, for example. So I'm going to build a list called results, which is initially empty, and I'm going to run for rep iterations using the range function. Okay, this is a very very simple way to build a for loop. For it's complaining for a variable I in a certain range. What will I do? Well, basically, I will call this function, battles to next rank. And then I will call it with the points for a win, points for a loss, the win probability, which in this case I have set to 50% again, and then start and end. Okay, start and end. I'm going to call this and put the results in this results list. Okay. What is a list? Where do I find that? That's the first unit in the second course. So in due time, we can have a look at those. Lists are data containers that basically include structured sequences, what you would use as a list in real life too. Okay, so I'm going to be running this. Okay, I have an error here. Yes, because here I put a point instead of a comma. I'm trying to do all this code as I explain so that you see that I also make errors, and that programming errors and mistakes are every programmer's bane, and they are normal and useful. Okay, read the messages. I'm correcting them very quickly. You will probably need some more time. Don't worry. That's normal, and that's part of learning to program. Okay. So I have now done 10,000 repetitions and put them in this results list. Okay, the count in every time. But I want the average of that. So let's do something like, and I'm going to copy this one. Let's do something like here. After the loop, after the loop, on average, we needed the mean of these battles to reach master rank. Okay. So now we have a very, let's say, deep analysis on this very silly problem. We started just with a very superficial type of solution. Okay, I get approximately 3 points for every 2. Then we added this probability of winning or losing a battle. It's a fixed one. And then we have used this code with this probability to simulate the process 10,000 times. Okay, I can even make this a little bit more compact too, because as you can see here, I have a list and I have 4, and that can be transformed very easily into something called list comprehension. Okay, so I want to do a list that contains this thing. For this range, okay? And now with this other syntax that doesn't need the for loop, I have again the exact same thing, okay? Now it took 494. I'm still getting different results every time, okay? But now they are much more stable because I'm repeating the thing 10,000 times and doing the mean. Can I repeat it 100,000 times? It will probably take a little while longer, but yes, I can repeat it too. Okay, I can do my experiments as long or as short as I want to. In this case, by the way, I can use this moment. Okay, no longer. But if you click here, you can see the resources on your computer. You can check a little bit more about this in this how to use Colab for the course video. But basically, this code is now running in a distributed Google computer. Okay, and if you click there, you can see the resources of that computer and make sure that your code is not running out of RAM or of disk or whatever. Okay, in this case, running 100,000 repetitions didn't even make a dent on the RAM, as you can see here. Okay, so just a little example of how coding different levels with more compact or not so compact level, sorry, not so compact code can help me get answers to this admittedly not too deep, but surprisingly useful example code. Okay. I'm not going to have time to do it now, but I wanted to propose to you also a second task. In this task, it's how to get from the previous level to the Ultra Bowl rank. And the thing here is that additionally to having this points for a win and points for a lose, in this case, the points for a win are 10 and the points for a loss are -5. So not -7, but -5. If this was the only difference, we could solve this by only putting a -5 here. We also get win streaks. Okay, so if you win 2 times, you get 3 extra points. So at the second win, you do not get 10 points, but 10 times 3, 13. Okay. In the third win, we get sorry, 16 points, fourth win, 19 points, and every win after the fifth or after, we get 12 extra points. We get 22 points in total. We start with 200 points and we need to get to 710. Okay, so can you reuse some of this code to model how many battles do you need to get from the Great Ball rank to the Ultra Ball rank? So have a look, see if you can model this. And this is going to be mostly it from me today. Let's see for a second if there are some questions. No questions at this moment in either Slack or web class. If you had problems following the course, if you have problems with the English, okay, if there was something that you could not follow properly, let me know and we will try to fix it. Today, the goal was just to get general feel for the course, for the things that we will do for the people that are here, okay? Next week, we will be starting with the first project, which I will publish during today, initially only in English. After reading that, you really need a Japanese version, let me know and we will do it, okay? Go and have a look at the courses that you need, okay? For project 1, you will be needing all the notebooks in course 1 plus the first one in course 2, okay? If you are already good at programming, you probably want to have a look at the ones that speak about the pandas library, okay? And probably about these examples. And these 3 examples, which will give you a little bit of a window into some more advanced programming contents. Next week, we will be speaking about programming basics, about the pandas library a little bit, and we will be doing some coding regarding the first programming project. Thanks everyone for listening, and we are going to give 1 minute in case anyone has a question, a very pressing question now. Does anyone have a question that they really need answered now? Okay. No pressing questions at this moment? Okay. So I'm going to finish the meeting at this moment. See you again next week, same hour, and communicate with all of you on the internet if necessary. Thanks everyone for attending.